All right, good morning. Yeah, we have camera action this morning. That's awesome. I'm not like the only person in the universe anymore. All right, how is everyone? Good, good. Yeah, I can relate to sleepy. My grand plan for being well rested this quarter has come to a conclusion. But that's okay. So I would like to go over Euclid's algorithm tomorrow, actually, when we talk about PA1. But if we have a logical point to do it today, we can do it today. It's a pretty straightforward algorithm, and normally we do it in CSE223A. I did not get to it this year, but we'll do it either today or tomorrow. And I had a request to go over toString, so let's start with that, and then I want to talk about other aspects of making classes. Here, I'll join the camera crew. So let's play with toString. Okay, you must have taken 215 sometime other than this year, because I don't think I got to it in either fall or winter. Huh, maybe I did. Okay, awesome. All right. So let's just play with a rectangle class. So we were doing a triangle class yesterday, and then in the afternoon I did a rectangle, and that's what I have left here. So here's a rectangle class, right? It's an object that is going to have a length and a height, right? And there's an area method which returns the length times the height, and here's a multiply method. We had a way to add triangles yesterday, so here's a way to multiply rectangles. I know our triangle, well, no, it's still on the server. It still survives. It's in Stovacore or whatever, because it was in battle. So here's the deal with toString. Let me get rid of this first. Let me just name this haha toString. And here's our main class with our main method. Yay. So we've got a rectangle R1, which is a new rectangle that's 10 by 5. We can print out the area by using the area method in that rectangle, and then we made a 5 by 5, and we printed out that rectangle area, and then we multiplied the two rectangles to get R3, printed out its area, and then we have three print statements where we just concatenate those rectangles to a string like R1 equals R2 equals, and we print out the result. And so let's run this, and I don't have a toString method right now. Okay, I renamed it to something else. And when I try to convert the rectangle to a string, it turns into this thing that's meaningful to Java but not really to us. Plus is concatenation. So let's actually just play with that right? So I'm setting s equal to a string. Here's an int, and I'm saying concatenate to that string the value of I. Well, I is not a string, it's an integer, but the system is going to convert it to a string in a reasonable way. And then I tack on the string and a real number, and I ask it to concatenate with a typo in my line. I ask it to concatenate x, which is a double number, and then I concatenate another string, and I ask it to concatenate c. So plus join strings together, exactly. And if I print out s here just in the beginning, right, it does what we're hoping. Yeah, and this is a little more civilized than %ds perhaps. Yeah, concatenate's just a fancy way of saying combine or join together. All right, so yeah, this is one reason we do C first, right? Because once you've done something very high level like Python or Java, you're never going to want to do C again for a while. All right, so yeah, that's what the plus sign is about. And you gotta be a little careful with this. We may as well break this out now. Right, so we could set s2 equal to x comma I equals and concatenate x and I, and that's not going to work very well, right? Because plus sign also means addition, right? And it's taking this as concatenate x to the string, but then it's trying to take that string and add an I to it, I think, or something like that. And if we just wanted to set a string equal to, oh, never mind, it's a typo. That works. But if I just want to convert an integer into a string, right, like this, that's not going to work. And so sometimes you'll end up doing something like this. Like I'll force it to convert I into a string by saying, well, let's take this empty string and let's concatenate an I to that, and that will force I to turn into a string and then be appended to an empty string, and so that's an easy way to just convert a variable into a string. Cool. I love that quote, man. Yeah. For a more civilized time or age. Yeah, I love that. All right. So two strings, right? If I try to take an integer or a float and convert it to a string, it works, right? It knows how to do that. If I try to convert a rectangle, right, R1 is a rectangle, which is the class I created, it doesn't know how to do that. And so it gives us this funny string representation. So what we're allowed to do is write a method that will help the system convert our objects into a string. And so your method has to be public, it has to be called toString, it has to return a string, it has to take no arguments. And in this case, you know, I'm going to return the string, which looks like this. The word followed by the length, followed by a times, followed by the height, followed by the word rectangle. And then when I try to concatenate a rectangle to a string, the system will call this toString method, and this toString method will return this string, and that's what it will use as the string version of our rectangle. So now when I try to print it out, it says these nicer looking things, R3 is a 50 by 25 rectangle, and so on. And it's just a very particular method, right? It's got to have this name, no arguments, returns a string. And as long as it's set up like that, this is what will get used when we want to convert a rectangle to a string. Cool, you're welcome. So this is a good time to mention signatures. So in C, I can make a function and here's a function called fun, and it takes an argument which is an integer and it returns an integer. What's it called? I think it's just called overriding, at least at this time of day. That's the best name I can come up with. So you're overriding a method in another class. So in C, I can make a function. It takes an integer. It returns an integer. If I now try to call my function with a string, the compiler will probably accept that. It might give me a warning, but it's gonna do weird things, right? Because if I'm adding 1 to x or something and I try to add 1 to hello, that's gonna do goofy things. Or if I tried to do something like character C equals fun 17, I try to return the value as a character, right? That's going to do funny things and so on. And if I were to try to make another function somewhere in my code, right, declare another function that takes a string or returns a character, the compiler is going to yell and scream, right? Because in C, basically, your function is specified, it's identified by its name, right? Anytime I call fun, it's going to call this function, even if I'm not passing an integer. So in Java, things are a little more nuanced. So we have this notion of a signature. And the signature of a function is the name plus the types of arguments. Which kind of implicitly says also the number of arguments. So let's do something. Let's make an integer function. And let's yeah, we're getting a little strange now. Okay, we'll just be strange. This is really weird because I'm writing a function that has nothing to do with rectangles inside the rectangle class. But work with me on this. Okay, what I've just written here, this will work perfectly fine in Java. I have two functions named fun. They each return an int, but one of them takes a single argument, which is an integer. The other one takes two arguments, which are integers. The first function doubles that argument. The second function returns the sum of its two arguments. And this is totally legit in Java. And yeah, this is related to having multiple constructors, exactly. So if I've got a rectangle here, let's just Alright, so I can call, r1.fun with an integer. I can call r1.fun with two integers. And, fun of 2 returns 4 because it doubles its argument. Fun of 2 comma 3 returns 5 because it adds its arguments. Cool, alright, so some people already figured this out, which is great. Alright, it also depends on the type of argument. Right, I could have a version of fun that takes a character and returns, I don't know, just some fixed number for whatever reason. Let's see. Yeah, so we can fake default parameters, and we're gonna play with constructors after this, so we'll see some ways to do that. Specific order your class should be in. I don't actually know what most people do. I usually have the class, definition at the top, and then I probably put whatever fields are going to be shared by all my methods, and then I put my constructors, and then I put the general methods after that. And I would probably put public stuff in front of private stuff. Single quotes is a character, double quotes is a string. And if I just used x without quotes around it, it would think that I was trying to pass the value of a variable x. And if it existed, it would pass that. If not, I'd get a compile error. Alright, so we'll talk about the signature of a method. And the signature, again, is the name and the types of arguments that it expects. So this is called fun, and it expects an integer. This is called fun, and it expects a character. This is called fun, and it expects two integers. Those are three totally separate functions, nothing to do with each other, right? They have the same name, but they have no relationship to one another. Right, other than if we actually like make some relationship between them. So the method is the method definition the signature? Basically, yeah. Now the type of return value is not part of the signature. I can't have two functions with the same name, same types of arguments, and different return values. Right, but the signature is the name and the types of arguments going into the method. All right, let's see. So methods don't have to have arguments coming in. They don't have to have arguments, have values coming back, right? We could make a method to modify a rectangle that actually doesn't take any arguments and doesn't return anything. So let's make a widen method that's going to take a rectangle and make it really wide and short. So how are we going to do this? If I have a 3x5 rectangle, how do I make that really wide? Well, assuming I'm sticking to integers. I could make this 15 by 1. And I want to write a method that if I call the widen method, it will change the dimensions on a rectangle to make it look like this, right? Which means basically the length should be the area and the height should just be 1. Alright, so this is an example of like using all of this stuff the way that we kind of want to be using classes. So I'm just going to say length equals area. And height equals 1. Alright, so what's happening in here? There's a bunch of things going on, right? I'm calling a method area. I haven't said, you know, something dot area, just like I haven't said something dot length or something dot height, which means the area method that I'm calling is the one inside whatever object I'm in. If I say r1 dot widen, then this is saying r1 dot length equals r1 dot area, right? And the area method, which we wrote somewhere, do we write an area method? Yeah, right here is just going to take the length and the height and multiply them and return that. So if my length is 3 and my height is 5, right, this will call the area method. It'll return 3 times 5 is 15. I'll set my length to 15. I'll set my height to 1. And this, you know, looks like, you know, kind of how I was thinking about this, right? Set the length of the area, set the height to 1. And so here's, let me comment these out. So here's R3, right? And then let's say R3 dot widen. And then let's look at what R3 is after that. Alright, so R3 changed into a 1250 by 1 rectangle. Alright, and you can use this in PA1. If you've looked ahead to PA1, I talk about maybe normalizing your fractions, right? You can make a normalize method that adjusts your numerator denominator to put it in whatever you consider to be a reasonable standard form for whatever you're going to do. Alright, so we know about signatures. We can have the same method, same name, but different types of arguments. We can use this when we create constructors. So my constructor for a rectangle, well, I didn't even specify a constructor, right? But I could. So let's make a constructor. So let's define some constructors. So to make a constructor, it's got to be public. It does not specify a return type, and it's named whatever the name of the class is. And let's pass this L and H. And that's all I'm going to do in my constructor. I'm just going to set the length of my rectangle to L and the width of it to W. Alright, I've suddenly got a bunch of errors. Yeah, I need to like find some different term. Thank you. Alright, length and height. I'm going to like tattoo it on my arm or something. So I've got a bunch of errors now, right? And the errors, again, let's look at the first error that comes up. Constructor rect and class rect cannot be applied to the given types. R1 equals new rect. Okay, so what just happened? There's always a default constructor when you write a class. If you don't specify a constructor on your own, there's a default one. And it does a minimal amount of stuff. It basically allocates memory and makes a reference to it. And that's more or less it. But now I've specified a constructor of my own. Well, the default is no longer available. Okay, it's just the way that Java is set up. Once you specify a constructor, there's no default constructor anymore. And these messages are very explicit, right? So it's telling me constructor rect and class rect cannot be applied to the following types. R1 equals new rect. Required integer comma integer found no arguments. Reason actual and formal argument lists differ in length, right? If you know how to read this, this is extremely straightforward, right? It's telling you, hey, you need to pass 2 integers and you passed nothing. You passed no arguments. So suppose I do want to be able to construct without any arguments. So let's do this. So what should we do if we try to construct a rectangle with no arguments? I don't know. Let's make a 1 by 1. All right. So there's our default constructor. And now if I try to compile, there we go. All right, let's see. I'm lagging on questions. Freeing memory. If you make a temporary object, don't use it. So yes, Java has a garbage collector. So we don't have to worry about memory leaks. If we allocated memory, if we created an object and we're not using it anymore, meaning we've lost all references to it, there's a process in the JVM called a garbage collector that runs around and picks up these unused, inaccessible areas of memory and reclaims them. So theoretically, we don't have to worry about this. And so there's no real option for running Valgrind that I know of. Maybe somebody's written something you can use. But for example, in my main program, if I set R2 equal to new rectangle, and then I set R2 equal to another new rectangle, that old rectangle is lost, right? If there's no variables referring to it anymore, it's basically wasted memory. And so that's the thing that the garbage collector will eventually pick up and return to the memory pool. And you can force that to run if you need to, but usually it does a pretty good job of managing it itself. All right, so our code compiles, but let's go ahead and let's make our rectangles a better way. So instead of doing this, I could simply say R1 equals new rectangle 1010. And when I run that, you know, R1 is a 10 by 10 rectangle. And so this is more convenient, right? Triangles are everything, man. That's like what the whole world is made out of. All right, so we can do this, right? Or we can do that. Now, in addition to being more convenient, there's another reason we might want to do this. Yeah, but what are polygons made of? Right, take any polygon. Yeah, there you go. So let's make a weird rectangle. Wow, that's an interesting idea. If quarks are triangles. So let's make a weird rectangle, which is a 10 by minus 10, and let's print out its area, right? So let's compile that up. I knew I messed something up there. Right, so we have a rectangle with an area of negative 100. Right, which is a little weird, but it's going to be even weirder if I try to find the length of the diagonal, right, of a square with the same area, because I'm going to try to square root negative 100. And this is just strange, right? This is not something that we want to do. So what could we do? We could put something in our constructor, right? All right, so we can say, in our constructor, let's check to see if they've requested something that we consider unreasonable, and if so, then we're just going to give them a default rectangle. Now we could print an error message in here. Be really careful about what you print from, right? Unless this is totally your thing and you're the only person using this and you don't mind getting print statements at random times, right? I would avoid printing in the middle of constructors and things like that. But we're doing something reasonable here. So let's compile this. It's just going to be like height equals width day. Let's compile that. Let's run it. And what happened? Oh, I forgot about weird rectangle. Yeah, so the weird rectangle had an area of 1. Imaginary numbers are cool, yeah. And they do work in AC signals. And all the stuff you do with KVL, KCL, you can do it with imaginary numbers. And you can have imaginary resistances, and this gets you into like capacitors and inductors, which is cool. Does GDB work on Java? No, there is a Java debugger, JDB. I'll be honest, I've not had a lot of luck with using JDB to do debugging. But we'll play around with it a little bit this quarter. But it's not the same thing as GDB, which is the same idea. It lets you set breakpoints and look at values of variables and so on and so forth. Yeah, we are going to be using Eclipse, and Eclipse has a debugger built in that works pretty well. So we can debug with that. But for now, you're probably back to putting in lots of print statements to do your debugging. And that's not a horrible thing to do. I suspect after the world ends, people will still be putting print statements in their code to find bugs. Yep. All right. So we have the ability to control how objects are constructed, right? Because in our constructor, we can do whatever we want. We can validate the arguments. We can change what we're constructing. We could do print statements. We could calculate prime numbers. We could play chess. I mean, whatever we want, right? Usually a constructor, the purpose of it is just to create an object. And if we pass arguments, that may modify the characteristics of the object we create, right? But really, it's just another method that's going to return an object in the end. So typically, we'll initialize things inside our constructor, but a lot of times we'll do validation as well. So let's our weirds area equals this. Alright, so we save the user from making a rectangle with weird dimensions to it. But there's nothing to stop the user from doing this. Right? So we can't, you know, stop. We can't force them to use a non-negative number when they write a statement like this. Which means that potentially, you know, they could make the length or the height of their rectangle negative, which might cause us all kinds of problems. What we can do, though, is we can prevent them from being able to write this statement at all. And so this is where public-private comes in. So we can control access to different parts of our class. Yep, you got it. Alright, so here's what I'm going to do. I'm just going to add 2 keywords. I'm going to change each of these to private. And now when I try to compile, right, every time that I tried to specify the length or the height, I'm going to get an error. So this is not a big problem. So R1 we constructed as a new rectangle that was 10 by 10. And yeah, we're going to get into getters and setters next. You got it. So this is going to be a 2 by 5. This is going to be a 5 by 5. And then R3 will still be multiplied. Did we catch all of them? Okay, so we got everything except, you know, where the person was trying to be weird. You use private methods partially to save yourself, but more just because, you know, you don't want to expose more than is necessary, basically. It's kind of a general conservatism. It's more interesting when you think about sort of making a class that's going to be used by other people. For example, the string class, right? There's probably a field somewhere in the string class that stores the length of the string, right? And when you concatenate something to the string, that length field is adjusted, right? And there may be some method for doing that. Well, you know, if somebody outside happened to call that method, you might create inconsistencies, right? If they adjust the length of the string, but they haven't actually changed the string, stuff like that. So it's just yeah, like guardrails and bowling, exactly. And in C, you know, everything is open, right? In assembly language, everything is open, right? You have access to, you know, theoretically the entire memory space. In C, anything that you've written, any global variables, any functions in your code is accessible. And we kind of think of that as the norm, but start trying to think of the norm as like, you know, you get to decide what's accessible, what's runnable, and so on, and those are the only things that are accessible. How do you get gutter balls with the rail up? That's impressive. Nerd bowling, awesome. All right. So this is great. This will save us from doing something weird. But suppose we want to know what the dimensions of a rectangle are. So let's do this. Right? I'm not trying to cause any trouble. I just want to know what the length of R1 is, because for some reason I care about that. Right? Well, I've got a problem. I've made length private. So I cannot get to that from outside the class. All right, so we're going to use what are called accessors and mutators, or sometimes they're called getters and setters, which should be like a band name, like Logan and Mancina. So accessors and mutators, basically we can't, access the length because it's been made private, but we can make a method that will give us the length, and we'll make that method public. So we're going to call this getLength, and the sort of conventional way to make an accessor for a variable named blah is to make a method called getBlah, but to stick to camel case, so make the first letter of the variable name uppercase. So I'm just going to make my accessors right up here. So I'm violating what I said about putting constructors first. So I'm going to make a public integer getLength. That looks like that. So I'm going to have a getHeight that returns the height, and I'm going to have a getLength that returns the length. And those are public. And so when I compile, I can access those, and when I run, I can get the dimensions of my rectangle. But if I try to set the length explicitly, I'm going to get that error because I don't have access to that field. All right. So if you want to read a field from a class, even if that field is private, you can make a public method that basically returns it, right? This works because even though height is private, right, this method is defined in the same class, so it has access to it. And so I can return the height. So that's called an accessor. And if I want to allow something outside the class to modify the value, then we create what's called a mutator. Not a mutator. So there's my setHeight mutator. And there's a setLength mutator. And so even though I can't set the dimensions by using the fields directly, I can say something like r1.length equals 127. Right, that's my syntax error because I don't have access to that. but I can say r1.setLength 127, and that works fine. And R1 became a 127 by 1 rectangle. Let's give it some height too. All right, and you know, there's nothing to stop me from doing this. And I'm back to something, right? But obviously what I can do is in my mutators, right, I can say if the length is bigger than 0, let's set that. And now it's going to just silently ignore my request to assign a negative length. All right, so that's a bunch more parts and pieces of object-oriented programming in our basket. So what have we done? We've done signatures of methods, right, which is the name and the types of variables in the argument list. We've talked about constructors and different signatures on constructors, so we can have multiple ways to construct something, and making things private and using accessors and mutators to interact with them even though they're private, and that combined with, you know, the general notion of classes and methods and doing things like, you know, combining things like, you know, where I use the multiply method of R1 to multiply R1 by R2, and I assign the result to a new rectangle R3, right? So the combination of all of that, that's basically everything that you're going to need. That's more than what you're going to need for programming assignment 1, other than Euclid's algorithm for finding greatest common factor. So my suggestion would be take a read through PA1 if you haven't done that already. And then tomorrow we'll mostly talk about PA1. We'll look at some sample main code that uses the class you're going to be developing. And then we'll go from there. Let's see, is Python semi-close to Java since they're both object-oriented? Kind of. So Java and C++ are very close to each other in some ways. Python I find very different, just because of some of the rules about typing. You know, types of variables, and the whole indenting instead of curly bracket thing feels pretty different. But object-oriented is object-oriented, right? If any of you have ever played around with Arduino hardware, you've been doing object-oriented programming, right? When you define an LCD interface and you say, you know, like LCD display space, you know, X, and then you say x.init, x.setCursor, x.print, right? You're using objects. This pops up a lot of places, and so Python, the parts of it that are object-oriented, yeah, very similar to what we're doing here. And, you know, a lot of the syntax, for loops and semicolons and things like that. Actually, you don't need semicolons in Python. But a lot of the constructs are similar also. And C++ is object-oriented C, but to me it feels pretty different from Java. There's just a lot of different ways that you do things like create classes, the way you import classes, and so on and so forth. All right, cool. That's all we got today. Take a run through PA1, bring some questions to class or office, and I will see you tomorrow.